This time I got a battery charger for some industrial equipment. Actually, I got two of them. They both don't work. And we're going to try to get one working from using parts from the other one. That makes sense? Okay, anyway, it's a just standard NiMH nickel metal hydride battery. Nothing special about this, just not working. So let's take a look and see why it's not working and what we can do to get one of them working. Got a battery charger to work on today. This one apparently is not working. This is for charging batteries that are used in a remote control for like a crane or a concrete pumper or one of those other industrial type applications. So apparently this is not charging. We're just going to check some voltages. I have another one here that also is not working properly that we can maybe take parts off to get this one working. Going to check for any output on the terminals here. There's 20 volts sitting on the terminals. And it's got an indicator that it's not charging. Now this other one here, the cord's been cut on it. He says this one doesn't work. We'll take these apart and see. I'm just going to try powering this one up. I'll just open the cable up and put my cheater cord on there. I want to see what this one does when I power it up. The second one here doesn't even attempt to turn on. No lights blinking or anything when I power it up. We'll pull the back off these units, or the bottom off them, and just take a look inside and see what they look like. I've never worked on any of these units before, so I don't know what to expect inside them. Okay, got a circuit board in here. Oh, this one looks like something's burnt. Pop the other one apart and take a look inside this other one as well. This one here we can clearly see that this, I don't know if it's an MOV. Oh, it's probably an MOV. It's burnt. It explains why it probably doesn't have any power. They're using this as a surge suppressor or soft start. The other one measures up about 30 ohms. This one here obviously is open, but I think that probably it goes right through to one of the input leads here. 1.6 ohms, yeah. So this is part is shot on this one. That would explain why this one does not turn on whatsoever. Now I can probably just bypass this thing for testing. It's all crumbling and falling apart. That's what we used to do on TVs when they had these thermistors on there, the soft start and the old RCA TVs. Just twist the stupid thing together and see if that would make it work. The crap out of there. I'll try powering this up once again with my cheater cord and see whether I get anything starting up on it. I'll throw this into the dim bulb tester as well when I test this. All right, let's power it up and just see whether this thing does anything. Oh, yeah, I had a bright light, which is indicating that this is short. Now the fact that the dim bulb tester lit up bright as anything when I tried putting that in with the bypassed MOV. I mean, it's not a short. There's no short on here. It's measuring like 2.3 mega ohms. Well, this one has a short, and if I put my meter, like the thermistor is, it's just there for surge suppression because these will operate on anything from 90 to 270 volts. So shorting it out is not going to cause a problem, which is what I did. I put a short across here to make it work. There you go. See, that's my input. Goes through this choke and it goes over to the bridge rectifier. There's no short here, but I am getting a short across the output, which means that maybe one of the output transistors are bad. If I measure across here, I've got a short. So I guess the first things first would be to we'll start disconnecting things and see where the short goes away. I'm pretty sure the short on this one's on this MOSFET here, which I don't have. I can confirm that by just lifting off one of the legs here. I'll lift off, I guess this is the drain or the source. Anyway, I'll lift one of them off and see whether the short goes away. But I bet this MOSFET is toast. So let's throw some solder on here. I like the way that they just stuck it to the bottom of the board. It's not a through hole. It's just been just stuck on the bottom there. Now let's just see whether the short has gone away, because that component is measuring a short. But and if I test the component itself, but my short has gone away here. I don't have a dead short anymore on here. This must be shorted. This transistor, this MOSFET must be shorted. I have a short. So across here. Isn't that weird? There we go. Yeah, that guy's shot. That's what's wrong with this particular charger, is that MOSFET is shorted. It's a TOP244G, which I don't have one. Might be able to get one, but I don't have one. This other one over here, this other charger that is apparently not working either. It's not charging, although it appears to be powering up. It's just not going into the charge cycle properly. Check this out. I think maybe these indicators aren't, I think this thing might even be working. It's just that the indicators aren't lighting up, because that looks like that's been eroded through, doesn't it? I mean, this one's got power. It's got 20 volts getting to the terminals under no load conditions. So, I mean, it appears that it's working. I'm just going to throw the screws back into this just so it'll hold the board in place. And we'll do some tests. I wonder if it's just that light that's bad, the ribbon cable. And he's not getting the indicators that the battery is charged or that it is charging. That might be the problem. It might just be the indicator is not working. This is not a lithium battery either. This one it's a nickel metal hydride battery. So you don't have any fancy cell balancing circuitry or anything. It's just a basic charge until the voltage curve changes, and then shut it off and turn on the other light to say that it's charged. But that definitely looks like that's worn. I wonder if I can take this other one. Is it in better shape? See, this one looks to be in better shape. I wonder if I can pop the lights out from one. This one here has definitely got corrosion in here on this. Though it does have the clips that have not broken off of it. Like this one, the clips have broken off. That's why I put a spacer. I think it's a pencil. You just put it there as a spacer to hold the battery in place. Because this one here, this one has separate little clips. Well, I can try plugging the LED from this other dead one. Plug this LED in. See whether this one lights up any different than the other one. This one lights up charge, and it's flashing charge. Just check the voltage going to the battery terminals on here. It is charging at 3.6 volts. So this should be charging. I could certainly put my current meter on here and see what kind of power it's drawing, but it does appear to be charging. Now whether these lights are going to light up when it's done. Oh, there, the ready light just came on. I bet you that's all it is. It's just the it's just that connector, that ribbon cable. I just discharged the battery a little bit. And the charge light comes on. Fast charge, when you press it, the fast charge comes on. Let's just see if the ready light comes on. I'm just going to let it charge here. I think that's all that's wrong, is that ribbon cable, which has got the switch on it here to switch fast and normal charge, is bad, and I can just probably pop one off and put it onto the other one. I'll just remove the terminals from here. From the bad board. I don't know that this is a problem, whether this corrosion down here is a problem. I think it's just water got into it, so it might be okay. I'll just check them for continuity. They may be okay, just clean up without having to swap them over. So the positive terminal is the one closest to me. Yeah, that one's good. And the negative terminal is this other one. Yeah, I think I'll just swap the board. Put the this cover, the good cover, on the good board. Okay, there's the bad one. And the good one is this one. Solder those down. Make sure that they're through on both sides. Which it is. And making a good connection. Okay, the base back on. I'm going to check the charging current with my ammeter here. So I'm just going to put it in series with the battery. I'll power it up. And the battery is now not connected, obviously. But when I touch down the positive terminal here, then I will complete the circuit and it will start to charge. It's charging at 90 milliamps. I think it should probably charge. Well, this is a nickel metal hydride battery. I don't know what the charge current on these are, but it's charging it at about 90 milliamps right now, because I'm in the 10 amp range. But it is charging. I just wonder if it will fully charge this battery and it'll switch to ready once it's done. Almost 100 milliamps, and that might be normal for this unit. I cleaned up the terminals on the case here where that corrosion was. Now we're at 100 milliamps. I bet you it's charging correctly. What I'll do is I'll reconnect the wire permanently, get it off the meter because there's no point, and we'll see if the battery charges up fully and the ready light comes on once it's charged, because it seems like it's working. The light's solid. If I switch off fast charge, I guess I can't unless I take the battery out. It starts out at normal and then you press the button and it goes to fast charge. But it appears to be working, so I'm going to throw this back together and we'll see if it fully charges. I got it back together, put it on to fast charge, and we'll see what happens, whether it'll charge the battery up and whether it will switch to ready once it's done. As to say, this thing's supposed to put out 300 milliamps, but again, I think a lot of it is dependent on what voltage is on the battery. If the battery is low, it's going to put out more current, and as the battery starts to get to its full charge, and this battery, I don't know what state it's in, but typically what these NiCad and nickel metal hydride chargers do is, once the battery starts to get up to its full charge state, they ramp the current down. So I think the unit probably is okay at this point. Typically how these work, as I think I explained before, is that when you first put the battery in, it measures the state of charge by measuring different parameters of the battery, like how quick voltages start to rise and so forth. And then the current is controlled by the charger itself, and it will ramp up the current to maximum current for charging. And then as the cells start to get closer to their full charge, there'll be a dip or a rise in the voltage that the circuitry detects, and then it drops the current down again as it gets to its full charge. Again, these are nickel cadmium or nickel metal hydride chargers, so they operate a little bit different than the lithium chargers did. But it appears to be working. We've got current going in. We measure it with the meter. It is charging the battery. It is putting power into the battery, so I think it's probably okay. I'm just going to let it run here. The fellow that owns it's going to pick it up, and I'm sure he'll let me know if it's not charging. But everything appears to be working now. We'll say thanks for watching. I'll catch you in the next one. Bye.